We live in an age of algorithms. These powerful mathematical models drive everything from our social media feeds to loan approvals and even criminal justice decisions. Artificial intelligence, or AI, promises to revolutionize our world, but there's a catch. AI systems can inherit and amplify human biases, leading to unfair and discriminatory outcomes. This is the danger of AI bias, a hidden threat lurking within the code that can perpetuate and even worsen existing inequalities. Imagine a hiring algorithm that favors male candidates over equally qualified female candidates, or a loan approval system that systematically denies loans to people from certain zip codes. These are not hypothetical scenarios, but real-world examples of AI bias in action. These biases, often invisible and unintentional, can have profound consequences, limiting opportunities and reinforcing existing societal prejudices. Understanding AI bias is crucial because it's not just a technical issue, it's a social justice issue. As AI plays an increasingly prominent role in our lives, we must ensure that these systems are fair, equitable, and accountable. Ignoring AI bias is not an option. It's a choice to perpetuate injustice and inequality. The good news is that we are not powerless against this threat. By understanding the sources of AI bias and implementing appropriate safeguards, we can harness the power of AI for good while mitigating its potential harms. This essay will delve into the complexities of AI bias, exploring its roots, manifestations, and potential solutions. At the heart of AI systems lies data. These systems learn from vast data sets, identifying patterns and making predictions based on the information they're fed. However, if the data itself is biased, the resulting AI system will inherit and perpetuate those biases. This is the crux of the garbage in, garbage out problem. One major source of data bias is representation bias. If a data set underrepresents certain groups or reflects existing societal prejudices, the AI system trained on that data will likely exhibit similar biases. For example, an image recognition system trained primarily on images of light-skinned individuals might struggle to accurately identify people with darker skin tones. Another challenge is historical bias. Data often reflects historical inequalities and injustices. For instance, data on loan approvals from a time when discriminatory lending practices were prevalent can perpetuate those biases if used to train a modern-day loan approval algorithm. The quality of data used to train AI systems is paramount. Biased data leads to biased algorithms, regardless of how sophisticated the underlying technology might be. Addressing representation bias and historical bias in training datasets is crucial to building fair and equitable AI systems. This requires careful data collection, curation, and analysis, ensuring that datasets are inclusive, representative, and reflective of the diverse world we live in. While biased data is a major contributor to AI bias, the design of the algorithms themselves can also introduce and amplify bias. Even with a perfectly balanced dataset, the choices made during algorithm development can lead to unfair and discriminatory outcomes. One type of algorithmic bias is objective function bias. The objective function defines the goal of the algorithm, what it's trying to optimize. If the objective function is poorly defined or reflects existing biases, the resulting algorithm may prioritize certain outcomes over others, leading to unfairness. For instance, an algorithm designed to maximize ad revenue might inadvertently prioritize ads that appeal to specific demographics, potentially excluding others. Another form of algorithmic bias is feature selection bias. Features are the variables or attributes used by the algorithm to make predictions. If the selected features are biased or correlated with sensitive attributes like race, gender, or socioeconomic status, the algorithm's decisions can be discriminatory. For example, using zip code as a proxy for socioeconomic status in a loan approval algorithm can disproportionately impact minority communities. The design of AI algorithms requires careful consideration and ethical awareness. Algorithm developers must be mindful of potential biases in objective function definition and feature selection. Transparency and explainability are crucial, allowing for scrutiny and identification of potential biases in the algorithm's logic. Even with unbiased data and carefully designed algorithms, bias can creep in during the interpretation of AI outputs. Humans are inherently prone to biases, and we often interpret information in ways that confirm our existing beliefs and assumptions. This can lead to a dangerous feedback loop, where biased interpretations reinforce and perpetuate existing inequalities. One form of interpretation bias is confirmation bias. We tend to favor information that confirms our preconceptions, while dismissing or downplaying contradictory evidence. When interpreting AI outputs, this can lead to selectively focusing on results that align with our biases, even if those results are statistically insignificant or misleading. Another challenge is the problem of correlation versus causation. AI algorithms are often adept at identifying correlations in data, but correlation does not imply causation. Mistaking correlation for causation can lead to faulty interpretations and misguided decisions. For example, an algorithm might find a correlation between zip code and creditworthiness, but attributing causation to this correlation would be a mistake, potentially perpetuating discriminatory lending practices. Interpreting AI outputs requires critical thinking, skepticism, and a willingness to challenge our own biases. It's crucial to distinguish between correlation and causation, avoid confirmation bias, and consider alternative explanations for the observed patterns.